So let's now make the comparison between manual machining and CNC machining. Um, with the CNC machine, the biggest advantage of all is that once the machine is set up and running, it can run on its own. What that means is obviously a CNC will need a certain degree of supervision, but this will change depending on what the component is. And a lot of components will be able to run completely on their own, and an operator can just go back when it's completed, and the operator can then just put a new blank on the table and press the cycle start button and let it machine through and again and make another component. Um, and there's a possibility that an operator could run several machines. So that's one of the massive advantages of a CNC. The other massive advantage with the CNC is it is faster. And don't forget that a CNC does everything. So it's picking up the tools, it's starting the spindle, it's running the whole thing. So all we need to do is load a component. So a manual machine would need an operator to be permanently on that machine. It A manual machine requires a level of skill because obviously um, there's lots of different things that that operator has got to be able to do. So in the old days of manual machines where they were used for production, which they're not that much used for now, these operations would be broken right down. So an operator would maybe be just doing one little part of a component on one machine, and then the next operation they would put on another machine. This was to simplify it so that you could have one person trained to just do that very simple part of that job. So it would be taken off that machine and moved to another. So you could have rows of machines all just doing very tiny parts of an operation, so that it was broke down to simplify it. CNC machines are a lot more expensive than manual machines, but this is changing rapidly because as with all technology, it becomes cheaper with time. So the things like servo motors and CNC controls and all the electronics in a CNC are getting cheaper and cheaper, so that now the main cost, which you can't change, is the actual hardware, meaning the actual structure of the machine, the castings, the tables, all these things that are no different on a manual machine. So the prices get closer and closer, really. When using a CNC machine, obviously, you've got to create a program, which is time consuming. You've got to do a setup. So it's got to be a much more reliable setup, because when you set this component up ready to machine, you won't be able to touch it. Once you press that cycle start button, it's just going to come in and carry on. So if something's not quite right, um, you won't always have the opportunity to adjust it. It's a bit like just taking a pillar drill and drilling a hole, and you can constantly feel the hole being drilled. You can feel how much pressure's on the drill. You can feel it wearing. You know this. It's just like drilling a hole in a wall with a power tool. You'll know if that tool's struggling. You can feel it. You can hear it. But with the CNC, you tend not to get this because you just program it, tell it what to do, and it just does it. And the next thing you know, the drill is broken because it just didn't cope. So you've got that empathy. This is why with manual machines, we tend to use them for training a lot, because people get the empathy with the material, they get the feel, they know what's going on. They know if they put so much pressure on that drill and it actually starts to bend, then they'll know it's doing that. So if we think about making, for example, prototype components where there's just one to be made and it's never going to be repeated, then this is where manual machines tend to be used. And and a manual machine obviously got that flexibility and you can just make it up as you go along, literally. But the big disadvantage is that having made a prototype, a component, if you want to make another one, if it's for development, and then your whoever's using that component says, well, it's not quite right, I need another one, but slightly different. Well, if you'd gone to the trouble of making it on a CNC, you would have a program, all your tools, everything ready to make another one. And all you would have to do is do those modifications that, say, a hole in a different place, which would be absolutely dead easy. And if that goes on and fails again and you need another, now you start to be really reaping the benefits of a CNC. The main thing with the CNC is the actual preparation time. There's a lot of setup time and preparation time, both programming and everything. But again, this is changing with technology. There's machines where you can program on the machine, and these are like a bit like using an iPad or something like that. They're very intuitive. So they're asking you questions. It says effectively, what do you want to do? You click drill a hole and it says how deep. So you're filling in questions and answers. So you're not really writing a program, you're just answering a series of questions, and the machine can actually create the program for you. So there's a lot of machines doing this, a lot of machines using combinations of this type of control with an actual inline G code CNC program. And this sort of thing will benefit your choice of CNC when you're first purchasing a CNC, because if it's for a tool room or it's for a development type shop, then you want a CNC that can quickly get the component on the floor. A completed component on the floor ready to ship or whatever it is you want to do with it. So you're looking at a machine that's got really good usability. It's easy to program, it's quick to program, um, and you can get the whole process completed quickly. One of the other things that you can do with the CNC that you wouldn't really be able to do with a manual machine is multi-load components. So if you've got a component that you're machining, and say for example it's a square block of metal, and you're machining around the outside and sticking some holes in it. Now what you could do, if that's held in a vise, there's nothing to stop you putting 4 vices on the table, on the machine table at once, and then repeating each tool as it comes on, jumps to the next part and does its work on each one. So at the end of that run of cycle, you have 4 components that you've machined. And you can even split operations. You can have one vice doing the first op, one the second, one the third, and so on. And you end up a bit like a car production line where you're putting them on at the beginning and they're coming off completed at the end. And from a productivity point of view, this can save massive amounts of time. And don't forget that if you were to pick up a drill, for example, and then drill holes in 4 components, there's the time to pick that tool up, what we call the tool change time, the time it takes the machine to change the tool. But if you use that tool for 4 components, if that tool change time was 30 seconds, then you've just divided that by 4. And the other great thing is that you can then move away from that machine and do something else. CNC machines also have what we call touch probes, and these touch probes can actually check the components. So a CNC machine can actually measure its own parts when they're done, and it can even make adjustments, and it's not that difficult to do. So you come in with this touch probe, which is it's just a probe on the end of a tool, and when it touches, it triggers the machine. The machine knows it's touched, and it does this really accurately. So it can touch your component in several places and create measurements as a result. You can also robot load a CNC machine, so you can have a robot loading it as opposed to a person. The other thing we have is what we call pallet systems, which means the components are all on pallets, which the machine can go in. These are like flat pallets with the components mounted on. The machine goes out and takes another pallet. And this can be called an FMS system, which is a flexible manufacturing system. And this is where you've got loads of different setups, and the machine just goes off and picks a component up, or a particular pallet, and makes that component. So you can have a family of parts on these pallets ready to do, and the machine can pick them all out. Another massive advantage of a CNC over a manual machine is repeatability. So the machine will repeat and repeat and repeat. Now, the only thing that really will change is the tooling. The machine will always go to the same place unless the machine's faulty, but it will always go to the same place. The tool may wander as it wears. The tool might not be capable of the accuracy that you're asking for, but the machine certainly is. So the repeatability is really, really good. And providing you monitor the tooling, you must monitor the tooling. In other words, say, well, this drill will drill me 40 holes, and then really I need to change it. So normally we'd just knock that back a bit and say, well, we won't do 40, we'll do 35 and keep changing. That way you get this repeatability and accuracy from that drill. Obviously, the other thing I've already mentioned, this is the level of skill. Now, a manual machine will require a higher level of skill because you're using hand skills, and but a CNC, once it's running, it doesn't require the level of skill. But to set it and to get it all going, is the same level of skill, because you've still got to know the engineering. You've still got to know about the cutting tools. You've still got to be able to know when this tool is worn, and what to do when it's worn. So that none of that changes. But you rely on, it's a bit like a carpenter carving a piece of wood. It's relying on these hand skills. Now a CNC, you don't need any of that. But with a manual machine, you will get an element of technique. People learning to actually, the actual technique of just feeding across the part or drilling a hole. There's actual skill to that, and it takes, in a lot of cases, it takes years of practice. The other thing about CNCs is the use of tooling. Now, there are tools that you can't use on a manual machine that you can only use on a CNC, and modern tools are designed for CNCs. That's because the CNC has that consistency. So when you start the spindle at a certain speed, it will always be spot on. The pressure when you're feeding and everything is consistent. The other thing is supply of coolant. So the coolant that goes to the tool on a manual machine is quite difficult. It's usually somebody with an old washing up liquid bottle just squirting the coolant on. Now with the CNC, you can completely flood. You can even have what they call Niagara coolant, which is like Niagara Falls. It just covers everything. So that makes it more efficient for cutting. And a lot of modern tools, they won't perform unless they've absolutely got this coolant supply really there. You can even get a high pressure supply of coolant to a CNC, which will make the tool perform much better. But modern tools generally are designed for CNC machines, not for manual machines. Yeah, one other thing about manual machines is that you do get more universal manual machines. So in other words, you get milling machines that you can tip the head over. So the head that drills or mills, you can actually tip that over at an angle. Or you can, usually they have configurations where you can put massive components on there and get to the side of that part. Whereas the CNC is very restricted. So if you buy a machine with an envelope of 600 by 500. In other words, that's the maximum area that it can move, is 600 by 500. You can't change that. There's no flexibility in that. And you can't suddenly get the tool and twist it over at an angle. Your machine is going to have a specific use, which is going to be limited. Whereas manual machines tend to be more flexible and more universal. So you can kind of make it up as you go along with a manual machine, but you can't do that. One other point is safety. Manual machines are way more dangerous than CNCs, because CNC machines, if used correctly, are fully guarded, fully enclosed. So when there's coolant, you don't get wet. If you hit the part will come out, but it won't hit you because the machine is all fully guarded, and you can't do anything with the doors open that's dangerous. So the machine will restrict you. So, and a point worth mentioning, these doors, if they have interlocks on, which means that these interlocks stop it from running when the doors are open. If they've ever been fiddled with, don't touch it, don't use it. But on a manual machine, you have to fit guards onto them. So manual machines tend to be more open, and you're holding your hands are much closer to the tools and the workpiece. So you can't just stick any person on a manual machine because it's dangerous. They've got to really know what they're doing before they use it. But with a CNC, you can literally say to somebody, push that button, and if you hear a funny noise, hit the emergency stop. And although it can wreck the component, it might even wreck the machine. It won't hurt the person. There's no danger to the person. So CNC machines are very, very safe, providing obviously that they use properly. And you can restrict what people can do on them. So you can say to an operator, all you do is open the doors, you put a new component into that machine, run it, and then when it stops, put another part in. But you don't touch this, you don't touch that, you don't allow him, and you can lock him out. You can lock him out of the control and everything. So just to sum up, a CNC machine is fully automated. It requires a lower level of skill to actually push the button and make the components. A manual machine tends to be more flexible. In other words, you can just make it up as you go along. You can drill a hole and think, oh, I'll go a little bit deeper with that. I'll just take that, drill a little bit deeper. CNC machines are more accurate. the repeatability. In other words, you just constantly get good parts off one after the other. But with a manual machine, every part is just as good as that, whatever you make that part. You don't get anything from the component you made before. So there are certain things in the setup that you can make it repeat. You can lock your tables, you can have like stops that you move the table to in known positions and things like that. So there are things that you can repeat on a manual machine, but generally each time you make a part, you're just starting from scratch. Everything is just completely. But with a CNC program, once it's ready and going, that's it. And the other thing with the CNC is that once you've made one part, it's very, very easy to make another and another and another. But with a manual, as I've just said, you've just, what if it took you 20 minutes to make the first part, it will take you 20 minutes to make the second part. Now with the CNC, it could take you 2 or 3 hours to get the first part off, but then every subsequent part will only be as long as the cycle time, which could be just minutes. So you could spend time setting it all and getting it all. And you do need to refine that setup. You do need to get it all right. Make sure make sure that everything is spot on. And then you hit that button and it will just keep making them. But with a manual machine, that never changes, other than the fact that your operator will get actually quicker at what he's doing. He'll actually get better at it, and he'll get slightly quicker. But if it takes him 20 minutes to make a part, he ain't suddenly going to make it in 3 minutes. And there's a massive difference in the production time. So typically, if a part took an hour to make on a manual machine, it would probably only take 5, 6, 7 minutes to make on a CNC machine.